Welcome to 3.3. We're going to be talking about the multiplication and division properties of equality. So just like in the last section, we were talking about the addition and subtraction properties of equality, how we can add or subtract the same thing to both sides of an equation. We can also multiply and divide both sides of an equation by the same thing. As long as we do it to both sides, we can multiply or divide by anything and keep the statement true. And we're going to see how that works. So the multiplication property of equality looks a lot like the addition and subtraction properties of equality. It says if you have two things that are equal, A equals B, and you multiply one of those things by something, you have to multiply the other thing by that same thing in order for them to be equal. Another way to think about it, if we have the same amount of money, and all of a sudden your money gets doubled, my money would have to be doubled for us to have the same amount of money, for us to be equal in that respect. And so whatever you do to one side, you have to do to the other side. And that's where this idea comes from. So let's look at an example. It's kind of an interesting example. So here's A over 3 plus 2 equals 7. And they want us to solve for A, of course, because A is the variable. Well, to solve for a variable, what I really want to do is I want to isolate that variable. To isolate a variable, I need to do the opposite of whatever's being done to that variable. So in this case, it's being divided by 3. That's the most urgent thing that's happening, immediate thing. So what's the opposite of dividing by 3? The opposite of dividing by 3 is multiplying by 3, right? It's also got a plus 2 happening. So what's the opposite of plus 2? Minus 2. And so that would take care of that. So that's the idea of kind of doing the opposite to undo the things that are happening to our variable in order to isolate it. And when you think about the order of operations, you typically multiply and divide first, and then you add and subtract. Well, when you're solving, you're often adding and subtracting first and then multiplying and dividing, which is why we learn them in that order. So let's apply the subtraction property here of equality. So I could say A over 3 plus 2 minus 2 equals 7 minus 2. So I took 2 away from both sides. Well, plus 2 minus 2 makes 0. So they kind of cancel each other out. So now I've got A over 3 on this left side. These blew each other up. 7 minus 2 is 5. Okay. Well, what number, when divided by 3, gives you 5? You may already know. You may not be sure. Here's how we can find out for certain. If A is being divided by 3, what's the opposite of dividing by 3? Multiplying by 3. Well, if I multiply one side by 3, I have to multiply the other side by 3. Well, 3 times something that's being divided by 3, well, they undo each other. So now I have, instead of a third of A, I have 3/3. Oh, that's a whole A. And that equals whatever the simplified version of 5 times 3 is, which in this case is 15. Now what's great is I don't have to just kind of do this work and then be blindly thinking that 15 is the solution. I can take it and I can plug it back into my original equation and I can see if it works. So instead of A, I'm going to write 15 over 3 plus 2 equals 7, just 7. Now let's see if it works out. 15 divided by 3 is 5, plus 2 equals 7. Now you might be tempted to say 5 plus 2 equals 7. That's true. But what I really want to do is I want to go all the way simplifying each side as much as I can. So 5 plus 2 equals 7 equals 7. That's a true statement. That checks out, which means my solution is true. Now, the division property of equality works much the same way. if two things are equal and you divide one thing by something, you have to divide the other side by the same thing in order for them to still be equal. A great way to think about it is, if we have the same amount of pizza, right? And my pizza gets cut in half, the amount of pizza I have gets cut in half. If we're going to have the same amount and be equal in that respect, yours would have to be cut in half as well. And so this is useful whenever we're solving an equation where our variable is being multiplied by something, where there's a coefficient in front of our variable of more than one, of course, because we don't write the coefficient of one. But whenever our variable is being multiplied by something like this, a useful technique to isolate the variable to solve for x, because I know what 4 times x is, but I want to know what one single x is worth. Well, to find out, instead of 4 times x, if I were to divide both sides by 4, that 4 divided by 4 would give me 1x, and then the only consequence is whatever happens on the right side, of course. So 4 divided by 4, that's 1x. Perfect. Those cancel each other out. Now, negative divided by a positive is a negative. 20 divided by 4 is 5. So that's the solution. And I can check it. I can plug it in here. 4 times negative 5, that is negative 20. So it checks out. So when it's a one-step problem like this, sometimes it's enough to check it by just visually inspecting it. When it's a harder problem, a more complicated equation, you may be better off writing it all out so that way you can check it for sure and know that your solution makes the equation a true statement. All right, so now let's put together some of our skills here and solve this slightly more complicated equation. So 5x minus 8x plus 3 equals 4 minus 10. Okay, we're going to solve for x. That's our variable. So the first thing I'm going to do is I'm going to simplify as much as I can. I see that I have like terms here, 5x minus 8x, and I see that I have like terms here, 4 minus 10. So on the left, I have two variable terms, and on the right, I have two constant terms that can go together. 5x minus 8x. So if I have 5 pieces of pizza and I promise 8 pieces of pizza to people, well, I am short 3 pieces of pizza. So 5x minus 8x is negative 3x. I have to bring down this plus 3 here, equals 4 minus 10, that's negative 6. I can go ahead and simplify there. Now I've simplified as much as I can, right? That part's done. Now what I need to do is start trying to isolate the variable. So what's happening to my x? Well, it's being multiplied by 3, and 3 is being added to it. The opposite of multiplying by negative 3 is dividing by negative 3. The opposite of adding 3 is subtracting 3. And so I will start with that. I'll start with subtracting. I'll take 3 away from both sides. So here, plus 3 minus 3 makes a 0, and that's exactly what I want. So my negative 3x comes down. That's the only thing left on the left side, equals negative 6 minus 3 more. That's negative 9. Now I know that negative 3 times x is negative 9, but I want to know what just x is. I want to isolate x. So what's the opposite of multiplying by a number? Dividing by that number. Dividing both sides by that number. A negative divided by a negative is a positive. 3 divided by 3 is 1, and that's why this works. So x equals, negative divided by a negative is a positive. 9 divided by 3 is 3. And if I want to check this, all I have to do is go to my original equation and plug it in for my variables and see if it's a true statement. So let's talk about some common mistakes that can happen. One is that if you're actually multiplying by 7, right, as in this case, 7 times x, that sometimes you might be tempted to subtract 7, say 7 minus 7, and then you get, no 7s anymore, and you just get x. But that's not true. And one way you can know this for sure is you can check it. So if you think x equals 14 in this situation, just plug it back in here. So the original problem is 7x equals 21. 7 times what number equals 21? It's not 14, right? Because if I plug in 14, you don't have to know what 7 times 14 is to know that it's way bigger than 21, right? Because 7 times 10 is 70. So you're already at 70. You're definitely going to be close to the hundreds at that point. So it's 14 is not a solution, and we can confirm that by checking it. So what would the solution be? It'd be 3. That's right. And we can see that by dividing both sides. Now, one thing that can sometimes trip students up is when they get the multiplication right, but then they do the opposite sign. Because when you are solving a problem with addition and subtraction, you do the opposite operation. But that's the key. It's not the opposite sign, it's the opposite operation. So the opposite of addition is subtraction of the same number. The opposite of multiplication is division by the same number. And so if it is positive to start, you should multiply or divide by a positive. If it is negative to start, you should multiply or divide by a negative, because that would be the opposite operation with the same number. And so the correct way to approach this problem, 7x equals 21, even though you know your times tables and you know 7 times 3 is 21, what I can do is I can say, well, the opposite of multiplying by 7 is dividing by 7. And as long as I do it to both sides, I keep the equation true. I keep it a true statement. 7 divided by 7 is a positive 1. That's exactly what I want. Equals 21 divided by 7 is 3. So that is the solution to that problem. And hopefully that clears up some of those common mistakes that can be made when practicing this material. So let's talk about the key concepts here. So use symbols to explain the multiplication property of equality. Use symbols. So I think what they want us to do is they want us to say, if A equals B, then A times C equals B times C. Right? So symbolically, I'm showing that if I multiply one side of an equation by something, and I say it's equal, that's what an equation is, right? Then I have to multiply the other side in order for it to stay equal. Let's have a look at B. True or false, multiplying both sides of an equation by the same non-zero quantity will never change the solution to the equation. True. Right? Multiplying by 0 turns everything into 0, so that has some pretty major consequences sometimes. So we qualify this by saying we're multiplying by non-zeros, right? Any number that's not 0. All right, let's have a look at C. If we were to divide the right side of an equation by 2, then the left side should be divided by 2. That's right. The exact same value. If you divide one side by 2, you have to divide the other side by 2 so that they remain equal. So hopefully that answered some questions you have. Maybe it sparked some new questions. If you've got questions, make an appointment, get in touch with me, and happy to answer them. Connect with the Tutoring Center, check out Brain Fuse Tutoring, and I'll see you in the next section.